I say 10.0.0.1 should be translated to 11.0.0.1. We are manually specifying. Okay, then .2 translated to .2. If we specify this individually, this is the static NAT. Alternatively, we have a dynamic NAT in which we will say 10.0.0.1 to 127. This whole range should get translated using 11.0.0.1 to 11.0.0.127 range of IP address. So maybe when a traffic from 10.1 comes, he may use 11.1 or he may use 11.10. We don't know. It's a randomly picked at the time of translation. This is the dynamic NAT. Fine. Okay. So, and both are NAT only. Now we have something called a PAT. What is PAT?
That is a port address translation.
Port address translation. What is happening there? Along with the IP address, the ports also can be translated. So we can say 10.0.0.1. If the port number is 80, translate it to 11.0.0.1. With port number 80, you can do that.
Okay,
If 10.0.0.1 with port number 22, translate it to 11.0.0.5 with port number 22. Okay, so here, but we are not translating the port number, right? But we are referring the port number. So alternatively, what we can do is, I can even say 10.0.0.1 with port number 8080, you translate it to 11.0.0.10 port number 80. So here actually the port number is also getting translated. This is the PAT, port address translation.
So IP also getting translated, port also getting translated.
Both we can do translation, yes. Okay, it's up to you how you configure.
Okay.
But in PAT, we can refer the port numbers also. Maybe just for reference of NATing purpose, or maybe for translating the port number itself. So for some reason, if you are referring the port number also in the translation, then that is called PAT. Clear? So in both the case, so as of now what we discussed, we do a one-to-one translation. Okay. In the dynamic NAT also we can specify with the source and destination range, translation range. So the number of IP address on both should be matching. Now we have something else which is called NAT overloading, or we call it as masquerading. This is when we have a range of IP address getting translated, but the translation range is small. So what we are doing, we have the translation range only 10 IP address, but the source IP address is 127 IP addresses. So how the translation will happen? First 10 communication can be translated to these 10 IP address. What about the 11th communication? We don't have a IP address available in this pool, right?
You will do the subnetting?
No. Subnetting is for allocation, not for the user traffic. Okay, when you want to assign an IP address to a PC, then we can do subnetting. But Subnetting and this traffic when it passes through the network, there is no relation. So in masquerading, what happens is for the first communication, I'll just clear the screen. For the first communication, ten dot zero dot zero dot one, when the traffic comes in, he will pick 11.0.0.1 and he will do the translation. 2, 3, 4 up to 10, he will pick one IP address and translation is done. Now when the 11th traffic comes in, I don't have a IP address to pick. So what I will do is I will use the existing IP address itself. Now I will use maybe 5. But now the problem is already the 5 is translated to 11.5, right? When the reply comes back, I will have a confusion. Reply is coming with the IP address of 11.5. But I have two entry in my, I can translate it to .5 or I can translate to 11 also. But which translation I will do? There is a confusion. To overcome this, they will use the port translation patting mechanism. What is that? When they do the translation, when they send a traffic, they will mark the port number also, right? So here from .5, maybe 22 port number is coming, so I will mark it as 22. But from 11, 22 is if it is coming. If it is 23, there is no problem. Both places I will mark 23. But if both the place 22 is coming, then what I will do, I will translate the port number also. I will use another port number instead of the original port number because there should be a differentiation between this entry and this entry. So both the traffic will
So,
pass to the destination. When the reply comes back, even if the IP addresses are same, the port numbers are different. So he can take a decision, this entry to use or this entry to be used. Got it.
so this is I'm getting confused. So 10.1.1.1, 2, 3, 4, 5.
Tell
So
me what
it's
is your
it's also
question.
same like a pat only, right? Then.
This is like a pat only, but
Hmm.
actually it is a patting mechanism we are using here. So it
Hmm.
is a patting mechanism only.
But
But the difference is in the patting what we do, we will say 10.0.0.1 with the port number 22. You translate it to 11.0.0.1 port number to 21. We will mention it. We'll specify it, the port numbers. What is the source
hmm.
port number? What is the translation port number? But in case
Hmm.
of NAT overloading, we are just saying these IP address translate to so and so IP address. We are not talking about the
Hmm.
port number. The port numbers are
Hmm.
automatically taken care by the device.
Oh.
That is the difference.
Okay, but we are not specifying here.
Now we are in case of NAT overloading,
Hmm.
we are not specifying the port numbers. But again, in NAT overloading also, we have two mechanisms. Statically we can do where we will specify it. Dynamically we will not specify it.
Hmm.
Okay. Any question?
Okay. But
Okay.
what is the difference between NAT overloading and PAT? Both should be both are look like the same. The main difference
See,
is
if I specify a NAT
hmm,
with the source range and the translation range with equal number
hmm,
of IP addresses, then
hmm,
it is
PAT. Hmm,
okay, normal path.
hmm, hmm,
Okay. Again, we can say, how to say, this is actually coming under the dynamic NAT, not under PAT, because we are just specifying the source and destination range. We're not talking about the
mm,
port number. If you specify the
mm,
port number also, then only it is PAT.
mm,
Okay. When you do the patting, and if you specify the port number and if you are using the same IP address, then that is again static PAT, or we can
mm,
say NAT overloading. We can say it's a PAT overloading actually.
mm,
We cannot
mm,
even
mm,
say it's a PAT because port number we are not overloading. We are using the
mm,
IP address only. So it's a NAT overloading, static
mm.
NAT overloading.
Okay, but in the
Okay.
case NAT overloading, we have a many IP address, and then we are when we are translating, we are using a less IP address, and then
But we are specifying the, we are not specifying the port number. Then it is a
port
NAT
number.
overloading.
But when the traffic comes right, comes back, will it differentiate with the port numbers?
He will translate both. He will translate this port number to
Hmm.
22, and he will translate the IP address also back.
Hmm.
Two translation will happen.
So then we are specifying only IP address, but the system automatically taking care
Internally,
of
it will do that. Yeah,
port
internally it
numbers,
will do that.
including.
If you are statically doing the NAT overloading, then whatever we specified, he will use that.
Hmm.
If it's a dynamic NAT overloading,
Hmm.
then system will take care of that.
Okay. Dynamic
Clear?
photo system will take. Okay. Dynamic photo loading. Okay.
So
Okay.
what is
This
the use case?
yeah.
One use case which we are doing every day in our life is translating your private IP address to public IP address when you have
Hmm.
your home based internet connection or small office
Hmm.
internet connection.
Hmm.
That even bigger organizations uses that. So if I have 5 PC, 5 laptop, mobile, right?
Hmm.
If we have
Hmm.
4 members in family, then they will have 4 mobiles, right?
Hmm.
They will have one or
Hmm.
two laptop, one desktop. So we already
Hmm.
got 6 to 7 devices in a home itself. But
Hmm. Hmm.
how is the internet connectivity? We are taking a Airtel connection. We are getting only one public IP address here. That means only one device can talk to internet. But all our
Hmm.
mobiles, all our laptops, everything is working, right? How is it happening?
Hmm.
Because your Airtel router is doing
Hmm.
nothing there.
Hmm.
If you check your laptop IP address, it will be a 192.168 dot range.
Hmm. Hmm. Hmm.
This is
Hmm.
a private IP address. This
Hmm.
IP address will not be allowed inside the internet. The Airtel first router, the edge router,
Hmm.
it will drop if any traffic is going with a private IP address.
Private.
Yep. So what we are
Okay.
doing on this router, we are doing an adding saying that
Hmm.
192.168.1.x, whatever the IP address is, translated to the IP address on this interface.
Hmm.
So when the traffic goes out, this device will see the traffic, any traffic coming from these devices, he will see
Hmm.
it as it is coming from this interface. This
Hmm.
interface have a public IP address, so no problem.
Hmm. Hmm.
And here I have a 256 or 255 IP address, right?
Hmm. Hmm.
But I'm
Hmm.
translating to only one IP address.
Hmm.
So what is that translation? It's a NAT overloading.
One minute to one.
Yes,
Net
NAT
overloading.
overloading. And it is dynamic NAT overloading. We are not saying the port number details. System will, right, look into the port number and he will map it properly to the corresponding device and everything will
Hmm.
happen in automatic.
Hmm. Hmm.
Clear?
Dynamic photo overloading.
Yeah. So this is one use case
Hmm.
of your netting, right? Now coming to another use case. Assume two organizations are merging,
Hmm. Hmm.
maybe
Hmm.
IBM, and they are acquiring another company, maybe called XYZ.
Hmm.
So even if it is a small organization, assume the company is big. Okay.
Hmm.
So
Hmm.
this will take time because in the IBM network, all the configuration will be saying that all the internal devices will have access to their resources. Anything outside, anything other than their specified IP address range, don't allow to the resources. That is how the configuration will be. So once the acquisition happened, once we make this connection, now these
Hmm.
XYZ devices they need to talk to this network, right? They need to access the resources because now they are part of the same company.
Hmm.
But as there are security configurations, they will not allow external IP addresses, different subnets. So what we need to do, we need to convert the whole network to the IBM standard or IBM
Hmm.
IP addressing and
Hmm.
configuration, security, all those
Hmm.
things we need to. It will take right maybe years.
Hmm.
You know how the merging happens in companies, right? Your employees
Hmm.
will get to know, okay, there is a merging happened, but it will take
Hmm.
some time to change the mail address, change the domain
Hmm.
name, right? To get the access to the resources, and a
Hmm.
lot of time it will take. Sometimes depends on the
Hmm.
size, it may take
Hmm.
years also to complete the transition process. So how till that time how the communication will happen? What we can do? We can in short we can do a netting. Whenever a traffic goes, this device will translate it to IBM range of settings, IP address and all those things.
Okay, there's a
And the,
translation happening from one private IP address to another private IP address.
we can see that depends how the network is, how what is the requirement, how is the existing configuration. Maybe sometimes we may have two netting.
Hmm.
For this company also they will have security configurations, right?
Hmm. Hmm.
So
Hmm.
any traffic coming from there, he will translate and send it inside. When the reply goes, he will translate and send it back. Or maybe he also may do. Depends how many branches,
Hmm.
right? Where
Hmm.
and all devices are there. Anyway, to allow the traffic to inside the organization, there will be a translation of the IP address. This is the
Hmm.
easiest and
Hmm.
shortest way to make these two networks to talk to each other. This is another use case
Hmm.
for NAT.
So basically, one set of IP address to another set of IP address we are
Yes.
translating.
Basically,
Then,
everywhere we are doing the translation.
hmm.
Only thing is the situation, the requirement changes. That's it.
Hmm. Hmm. Hmm.
The previous case I told for a home user or a small organization, they want to access the public internet. That is the use case. Here we are talking about two different company merging or two different right IP
Hmm.
segmented networks. We are merging them to talk to each other.
Hmm.
That is another use case. Clear? So now tell me,
Hmm.
NAT
Hmm.
is a stateless service or stateful service. First tell me what is stateless service, what is stateful service.
I think state full
Why?
because it is remembering the states.
Yes. See, whenever a NAT happens,
Hmm.
they creates a NAT table, which I taught before, right? That the translations that is stored
Hmm.
inside the NAT table.
Hmm.
Okay. So inside
Hmm.
this, we will have entries of all the current translations, whatever the current sessions happening through the
Hmm.
network, they will maintain in the NAT table. So that is called
Hmm.
state information. That is why we
Hmm.
call it as stateful service. NAT is a stateful service.
Hmm.
So when a translation happens, when the traffic goes out and they are making an entry, when the reply traffic comes back and if this table crashes, then the reply traffic will not pass through because there is no entry in the NAT table.
Hmm.
So if the state information is maintained in the NAT table, then only the communication will happen completely.
Hmm.
Okay. So this is a
Hmm.
NAT is a stateful service. Now there
Hmm.
is a small glitch here. What is that? We discussed yesterday, we can have a active or active standby edge.
Active standby. Okay.
Yesterday we discussed, right? Active and active
Yeah.
standby SR
Yeah.
routers, right?
Hmm.
So this
Hmm.
NAT is a service. So where is actually it is happening? Services are running
Hmm.
on SR routers.
Hmm. 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 Hmm.
So if your service is active, can you run NAT?
Active. We can run, right?
No. NSX-T is not supporting any stateful service if you are running active. Because
Wow.
in active what happens? One traffic will pass through this, another traffic will pass through this. Maybe when the reply comes, it may go in another way.
Hmm.
Both are active, no?
Hmm. Hmm. Hmm.
So the translation information is here. I don't know about the translation information.
Hmm. Hmm.
So the traffic will fail. Okay. So stateful services are not supported if you are using active service. So to overcome this problem,
Hmm.
we came up with another type of NAT. Okay. It is called see, I believe it is reflexive. Yeah. It is another type of NAT which is called reflexive NAT
Let's see.
or stateless NAT. If the NATing is stateful, then only it is a problem, right?
Hmm.
If I say I don't need a state information for my NATing, then the problem solved.
Hmm.
So how it happens is this is your router and you are doing NATing between these two networks. Okay. Now here, when you define a reflexive NAT, what happens is, as we discussed before, we will do the ranges. We will specify the ranges 10.0.0.1 to 127. Then 11.0.0.1 to 127. Okay, the conditions. First, this number of IP address should match with this number of IP address. If you have 128 IP address, here also 128 IP address, mandatory,
Hmm.
one condition. Okay. Second condition, or the way how it works is, the first IP address in this pool will use the first IP address in this pool. So 10.1 will always will get translated to 10.11.1.
Hmm. Hmm.
Second to second, third to third, like that. All one-to-one mapping will be there. Okay. So now assume that I don't have a net table.
Hmm.
Okay. From 10.10, I'm sending something to external network. So what translation will happen on this device?
10 to
10.10 will be translated to 11.10 always, the 10th IP address, right?
hmm.
So
Hmm.
there is no confusion. I don't need a table to refer this. We have two
Hmm.
range specified. I always will do the similar number of IP address in the pool.
Hmm.
Right, if the
Hmm.
10th IP address, then from the other pool, I'll take the 10th IP address. No confusion.
Then. Hmm.
So if I have two active device, then what will happen? When I'm sending
Hmm.
traffic, I'm sending through this.
Hmm.
So this is getting translated and traffic going to other side.
Hmm.
Now assume the reply is coming through this path.
Hmm.
Is there any problem?
Then.
He will see 11.10. So if he see 11.10, he know 11.10 should be translated to 10.10 and reply will come back. No problem, no confusion.
Okay.
But in the
It's a
normal
loop.
NAT,
Hmm.
there is no
Hmm.
condition like which IP address to be used. Maybe 10.1
Hmm.
may get translated to 11.100, maybe to
Hmm.
11.5. There is no condition. Any free
Hmm.
available IP address from the pool he will pick. Okay,
Hmm.
so this is the
Hmm.
reflexive NAT.
Hmm.
Any question?
So it is 10 to 1 to 1 mapping only, right? Then again,
Yes. Yeah, that is
it's
a
a kind of
condition.
hmm,
Then only you can do
same IP,
reflexive NAT.
same IP address mapping, same
Same, same IP address in the
hmm,
sense.
1010 or 1110, like that. The
No,
10
no, it
9
need
to
not to
9.
be number match. It is not number matching. Okay, right side
Hmm.
you can even use 11 dot
Hmm.
129 to 255. No problem. See here 128 IP address is there. Here also
Hmm.
128 IP address. That's it. So
Then
10th
then that
IP
case
address
it's
in
a
this
dynamic
pool,
hmm.
10th
group
IP
to
address in
group
this
to group.
pool will use 10th
Hmm.
IP address in this pool. That is the only thing.
But in the case, that is same like a group to group translation we are having, right? Same like, but we have to match the IP address, the
Number
number
of IP
match.
address we need to match. Yes.
Number of IP address we can match, but then in that case, it's a kind of dynamic net, right? This one.
It's a dynamic net only.
Okay. But you were explaining with the two routers, right? The left hand side, 10 to 10. I was not getting. I little. Uh,
Still not clear?
Yeah, the left hand side, the diagram which you made, right? Two router.
Ah, two
Possible you can
router I
explain.
am explaining with an NSX-T. This is the
Hmm.
SR of your
Hmm.
right T1 or
Hmm.
T0. That is what we were
Hmm.
discussing, right? If it is active, we cannot work. This NAT will not
Hmm.
work. Only for active standby it will work. But this reflexive NAT will work on active also. So two router I showed you to show that these two are active routers. Still reflexive NAT will work, and this is how it is working.
Both are active, then reflexive NAT will work.
Reflexive NAT will work, but the normal NAT will not work because
No.
they need a state information.
Okay. So in a active combination, reflexive NAT will work. So then normal NAT why will not work? That is also
Normal
we can
NAT, that's
configure. Hmm.
see here we have a NAT
Hmm.
table.
Hmm.
Okay, when 10.10 goes, this
Hmm.
router is deciding, okay, I will use 11.10.
Hmm.
He may use 11.100 also, no condition, right? He can pick any IP
Hmm.
address. Now
Hmm.
assume that the
Hmm.
reply is coming through this.
Hmm.
This router don't know, right? What is the translation used in the other router?
Hmm. 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 Hmm.
He will not have entry in his NATing table, so he cannot do the
Hmm.
translation. Then he will drop it
Hmm. Hmm.
for a normal NAT because normal NAT is working based on the state information in the NAT table. But in reflexive NAT, he is not referring any state table. He is just looking into the configuration and he know
Hmm.
if this is the 10th IP address, I need to use the 10th
Hmm.
IP address. That is it's unconditional, right? That is always that is the rule.
Hmm.
There is no other
Hmm.
choice.
Hmm. Hmm. Okay.
Fine.
Dynamic NAT. Question on dynamic NAT. Hmm.
And one more
But
thing, T0 can configure in active or active standby modes. But T1 is always active standby. There is no active option.
okay. T0 will be configured in active as well as active standby.
Your choice.
Hmm. But T1 will prefer only we have to make it active standby only.
Yes.
T1. Why is it so
That is how NSX-T is designed.
designed? Okay.
Yeah.
Hmm. Hmm. Okay, sir. Okay, sir.
Okay. Okay. Now we discussed about NAT.
Mm,
Now, what we are translating, based on that, we can say source NAT and we
mm,
can say destination NAT.
mm,
Okay. So if a PC
mm,
10.0.0.1 is sending a traffic to
mm,
20.0.0.1. So what will be the source
mm.
IP address? Source IP address will be 10.0.0.1. What will be the destination IP
Okay.
address? It is 20.0.0.1.
Mm,
And here is the router who is doing the translation.
mm,
And if he is
mm, mm,
translating the source
mm,
IP address, and when he
mm,
send it, he is saying 11.0.0.1 is the
mm,
source, and
mm,
traffic destined to 20.0.0.1. So here what IP address is changing? The source IP address is getting translated. Destination
mm.
remains same, right,
Same, same.
on this router. So if the source
Mm,
IP address is getting changed, then that is called source NAT.
okay.
If the destination IP address is getting changed,
Mm,
then that is called destination NAT.
mm.
Clear?
So if the source IP got changed, then it's a source net.
If source IP is changing, then that is a source NAT. If the
Mm,
destination IP address is changing, then that is a destination NAT. Again, I will tell you two scenario. Okay, use cases. So I told you the internet scenario, home based or small organization based.
mm,
This is source NATing. What we are doing, 192.168.1.x IP address, we are translating to this interface IP address. So source IP is getting changed, but the
mm,
destination, I'm trying to ping to Google or I'm trying to reach Google. So that destination will remain same from here till the end.
mm,
Only the source IP address will change. Clear?
not much
So
sense.
at home,
Mm,
our home-based
mm,
internet or small office, what we are doing is a
mm,
source NAT. Now, what is the
mm,
use case of destination NAT? For example,
mm,
at your home, you have your laptop,
mm,
okay, and you went to some friend's place. Now, from your friend's home, you want to access your laptop. You want to take RDP to your laptop. Is it possible? What do you think? Is it possible? Your laptop IP address is private IP address. From internet or from any part of the internet, you cannot access any private IP address, or you can say your internet is not aware about any of your private IP address. So if you are trying to access your laptop which is configured with a 192 IP address, you cannot access it from here. So what is the alternate option? On this router, you can configure a destination NAT. What we will do, from this device, I will do a RDP to this IP address. But on this router, I will configure if any source, okay, X source. If the destination is 202.0.0.1, then translate it to 192.168.1.10. Now what will happen? You can do a RDP from your friend's place to this public IP address of your internet connection, and this router will translate it to the 10 dot sorry 192.168.1.10 IP address, that is this IP address. So traffic will come here. So you will be able to access your private resources from public network if you configure your destination NAT. So this is one use case. So in source NAT, the source IP address was getting changed, but in case of destination NAT, the destination IP address is getting changed. Any question here?
Just I am thinking private to public only. Okay. I think this is scenario you explained previous also, but this is okay. Just private to public, right? There is the one. I think it is a
This
static net.
is
Uh,
this is private to public.
mm,
This is a source NAT.
mm,
Traffic is originating from here and
mm,
going to public network.
mm, 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 mm,
But this is traffic is originating in the public
mm, 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 mm,
and coming to your private network.
mm, 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 mm,
So your public IP address is getting translated to private, but
mm,
here
mm,
private is getting translated to public.
mm,
Reverse.
mm, mm,
Clear?
okay, here we are having a private to public. There we have
Again,
public to.
again, I'm telling you, private to public or public to private is just a sample. Okay,
Mm,
it is all
mm,
about the direction of the traffic.
mm, 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 mm,
Okay, so if you are translating the source IP address when
mm,
the traffic passes through your device, then it is a source NAT. If you are
mm,
translating the destination IP address when the traffic
mm.
passes through your device, then it is a destination NAT. That's it. Private, public.
Oh,
That's all.
okay,
Just
okay,
an
okay.
example. Okay,
Mm,
clear?
mm.
These all are
Basically,
CCNA concept. Okay, network basics. I'm not talking anything new. You are
yeah, yeah,
supposed to know these all things. Okay. Okay. Anyway,
yes,
this is like a revision for you, right? And if you are
yeah,
missing something, then it is like a gap filling. Good for you.
yeah,
Hmm?
yeah.
Only about NAT, I can talk another right a full session. I can take 3 hours at least. More than 3 hours, I can talk. Okay, that much is there. If I go in this speed, but if I go with
Yeah.
the packet structure, how the translation happens with examples, everything, then
Mm.
for 5 hours it will go.
Oh, okay.
Okay, that much information is there on that.
Mm. Mm.
Okay. Anyway, so overall, you got the idea. Any
Yeah, I got
confusion?
it.
Anything you are not getting?
No, 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 no. Source not
Okay.
destination only. Just source IP getting changed. That is what uh, source net and destination IP getting
Yes.
changed. Then that is a destination net.
Yes.
Okay.
Watch the video again and again. Okay, by
Mm. Mm.
seeing
Mm.
right how you respond, I understand that NAT is not so clear for you. So you
Mm.
repeat it, watch 2 3 times, then only
Mm.
right concepts will be clear.
Yeah, yeah, correct.
Okay, all right.
Okay.
So now we'll come to NSX-T. Till now we were
Okay.
talking about NAT, not about
Mm.
NSX-T.
Mm. Mm.
Okay, all right. So anyway, these all information is required for our NSX-T discussion. So we will see how the NAT is applied on your NSX.
Mm.
So we
Mm.
already discussed about a T0 and T1
Mm.
router.
Mm.
We
Mm.
can do
Mm.
NATing
Mm.
on both the routers.
Mm.
Okay, NATing is supported on your T0 and T1. Okay,
Mm.
all right. Now, as we discussed, source NAT, destination NAT, reflexive NAT, all are supported in your NSX. Okay. All right.
All supported in NSX-T. Okay.
Right. So these all are supported in NSX-T. Now this can be static or dynamic. Right. Whichever we can configure dynamic, that is also supported here. Okay. Now, how do you do? For example, if we have a T0 or T1, both are same way how we configure it. I'm taking T0 as an example. Okay. Now we have a web segment here, and I have web VMs here. Now, on this router, we will configure NAT. To configure NAT, the expectation is we already have our T0 deployed. The segment is created. Segment is connected to the router. VMs are attached to your segment, and there is a uplink connected to this. If it is a T1, uplink connected to T0. If it is a T0, then uplink connected to physical router, whatever it is. So the network is already up and configured. That is what the expectation for NAT. Now, on your NSX-T tab or your NSX-T UI, on the networking tab, you have on the left side, you need to uh, select your router. Okay, so you have two choice, T0 router and T1 router. You need to choose T1 or T0, whichever you want. You can select that. So when you select that router, okay, so sorry, that from the T0, T1, you need to deploy the router. Okay, and you make all these connections, everything. Then below this, you have a NAT option is there. So click on this NAT. When you click on this NAT, you will get a pop-up asking which router you want to use, T0 or T1. You can select which router you want to configure NATing. So once you select that router, then you will get a option below add NAT rule. So here you can specify all the rules. So what we are doing, we are selecting the router, then we are giving the statements. What are the translation we need? That's it. Okay. Now, where is this NAT will be running? On your normal transport node or edge transport node?
NAT will be running on T0 normal transport node.
NAT is a service, right?
Mm, mm,
Service will be running on
Edge.
edge, right? NAT is a service. Service will be running on SR component of your router, and SR component is running on your edge node. So, in simple words, your services are running on your edge node. Clear? Okay. So, when you write the NAT rule, you can say you need a destination NAT or source NAT or reflexive NAT. All those things we can specify. Okay, it's a GUI configuration. It is very simple, nothing complex in this. Okay, so most probably I will give you a lab. I will show you a demo. Okay, from starting from beginning to till today, whatever we covered, so that you will get clear. If you have any confusion, because lab manual when you read and do it, you may get some confusion, right? So, but I can explain it once so that all confusions will be cleared.
Okay.
Any other question?
No, no, sir.
Okay. So NAT is over. So uplink profile is simple. Did you say something?
No, no.
Right, okay. So uplink profile is basically it tells to the NSX-T from a host. We have NIC card, right?
Yeah.
Server will have a NIC card, maybe a 2-port NIC card or 4-port NIC card or whatever it is. So this uplink profile will tell to NSX-T how these NIC should be used for the NSX-T functionality, or the different parameters we will be setting to the NIC cards will be specified, because this is the ports which is getting connected to your physical switches. Okay, so we are going to define those details. So on the GUI, once you log in, system, then fabric and profiles. So we have different type of profiles. You can see here, we have uplink profile, NIOC profile, edge cluster profile, edge bridge profile. So there are a lot many. Okay. So what we are going to see now is uplink profile. Under uplink profile, you will have few uplink profiles already created. It is built in, right, when you deploy the NSX-T manager. So if you want to create additional uplink profiles, then you will click on add. You click on add, you will get this pop-up window. So here it's asking for a name. Then if you want to use a lag, what is lag?
Link aggregation.
Link aggregation.
Great.
Right? If you are using a LACP protocol for bundling multiple links of your server, then that you will specify here. Okay. Otherwise, if you are using normal teaming, then that you will specify here. Okay. Then here you are saying,
Yeah. Yeah, this uplink profile for this north-south connectivity towards
no,
leaf.
towards the leaf,
Oh,
yes, towards the leaf.
towards the leaf.
Nodes,
Uh,
nodes are connected to the switches. So
switches.
these links, how it should be used?
Okay, it's for then in that case it's a north-south connectivity, right?
No, it is just a physical connectivity. North, south, or east, west is based on what is the traffic which is flowing in the network. Okay, so
Then
if from the same node, if you are sending a traffic to other server, it is east, west. From the same node, if you are sending a traffic to outside world, that is north, south. This is a traffic what we are calling. The flow of data is what we call it as east, west traffic or north, south traffic.
So this uplink port can be used for both.
For both.
Can be either north south or can be both. It will be used for
Yes.
east west traffic also. It's north
Same
south
NIC.
traffic.
Same NIC will be sending
Uh-huh.
or receiving east west traffic or north south traffic.
Okay. So this lag is for teaming, right? This is a NICA
Yes.
teaming or specific
It is for NIC card teaming. If
team.
you have a LACP configured on the switch side, then on the node side, you will configure this lag.
Okay.
Lag configuration will support LACP protocol. Okay, so if switch side is LACP, then this side also it should be LACP. Otherwise, link will not come up.
Okay.
Okay. Now we are specifying something called a transport VLAN. What is transport VLAN? See, yesterday I told you from the nodes, inside the node we have multiple VMs, right? And these all VMs, when it reaches to the node, so that is node means server, the servers are acting as VTEP or TEP. So what is meant by VTEP? Tell me.
It is a virtual tunnel endpoint, right? So
Tunnel endpoint, right?
tunnel endpoint.
So we have tab. The
Mm.
servers are acting as tab. Every server is a tab. So what he does, he is doing VXLAN encapsulation and decapsulation,
Mm. 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 Mm.
right?
Okay.
So
Yeah.
the normal Ethernet traffic, when it reaches the node, this Ethernet traffic is getting an additional header of VXLAN.
Mm.
Then on top of that, we are getting a Ethernet header added,
Mm.
and it is going out to your next layer switch. If it is access ACK, it is going to the ACK switches. If it is a spine leaf, it is traffic will be forwarded to spine leaf, spine switches. Whatever it is. What is the traffic? Outer header is Ethernet. Ethernet means
Mm.
it is going as a normal packet which where the VXLAN is not visible to anyone. So if we are sending Ethernet traffic, this will be part of any VLAN. So through which VLAN I will send this packet or this frame. So to carry
Okay.
the encapsulated VXLAN encapsulated frame, we need to send it through some VLAN, then only it will go to the other side. So which VLAN will carry this VXLAN encapsulated traffic to other devices is what we are specifying in transport VLAN. Simply, it says which VLAN we will use to transport our encapsulated traffic from one device to another device.
Okay. This again, it's a east-west traffic.
No, again, I'm telling east-west is the traffic which is flowing. Okay. So this VLAN, he will carry the traffic. He don't know whether it is a east-west or not south. Both traffic can go through this VLAN.
Okay. Okay. From server to server, the VXLAN tunnel will be get established, and then the
Using this
traffic will
VLAN,
be
right? The tunnel is
using
getting
this way.
established, right? So how the tunnel is forming? Those tunnel traffic is passing through this VLAN, 113 VLAN.
113 VLAN. 113. Okay.
This
So
one.
again, this tunnel will go via leaf switch, or how it will be? This tunnel.
Tunnel will be going, see, whatever you have physical path, through that only your traffic can go, whether it is tunnel or your user traffic or whatever it is. So how is the physical connectivity you have? It is like this, right? You have connection from here to here, here to here, here to here. So if your user traffic is going from here to this VM, then this will use this path. Or alternatively, it can use this path also. If it is east-west. If it is north-south, again it is using the same path, but it will go to edge node. From the edge node, it will go outside.
So in that case, this VLAN need to be get configured in the leaf switch also.
On the leaf switches also, yes.
Okay.
Okay, if you don't know more in detail about spine leaf, don't think about spine leaf and complex it. Think about access AG network. That is simple, easy to understand.
Access, yeah, yeah. Correct. Access.
Right. So,
Some switch.
yeah.
Yeah.
So in this case, this 113 VLAN must be configured on all your physical switches. Your whole network infrastructure must be configured with 113. That is the prerequisite.
Transport VLAN. Okay.
Yes, transport VLAN must be configured on your physical infrastructure, and that VLAN you need to give it in NSX-T. If I say, if I tell to NSX-T, you use 113 VLAN, and if the network don't have 113 VLAN, then what will happen? NSX-T
Yeah,
cannot send the
forget.
traffic, right?
Yeah.
So this is the only one VLAN you need in your physical infrastructure for sending your traffic. Doesn't matter how many subnet you have, how many IP group you have, doesn't matter. Just one VLAN is enough on your physical infrastructure. Clear? So we are specifying what is our transport VLAN we want to use for sending the encapsulated traffic. Then we are saying, what is my MTU? What is MTU?
Maximum transmission rate.
Maximum transmission unit. That means
Yeah.
what is the maximum size of a frame which can be passed through your network? Okay. Normally it is 1518, including your header. 1500 byte is your actual frame, and on top of that 18 bytes of header will be there. So total a frame can have 1518 byte. But now what is happening here? We have a additional VXLAN header is getting added. We have a additional Ethernet header is getting added. So this will not be the default size, right? So the frame size is increasing more than 1518. That is the reason we are telling to NSX-T that okay, you can the frame size can be up to 1600 byte. That means again your physical network infrastructure must be enabled with MDU as 1600. So when NSX-T sends 1600 byte of data, your switch also should know that okay, I need to support this big size of frame, otherwise the frames will be dropped.
Okay.
Okay, so two configuration on your network infrastructure. One, you need to set your MTU. Second, you need to configure one VLAN for transport purpose. Clear?
So the VTAP IP that will be on a VXLAN header, right? The VTAP IP on the
VTAP
server.
IP address will be on your VXLAN header.
VXLAN. Okay.
Or we can say, so it's not exactly like that. So how we tell this is your original Ethernet. Then your VXLAN and header is getting added. Then your UDP header. Then your IP header. Then your Ethernet header. This is the actual. If I see inside, this will be the structure. So this IP address will be your tunnel source IP and tunnel destination IP. That is your VTAP IP addresses. Source VTAP and destination VTAP. Clear? And inside this Ethernet, there will be IP header. This IP header will have the source and destination, actual source and destination who is communicating this VM IP address and this VM IP address, source device IP address and destination IP address.
Okay. Okay. Inside VM IP will be there. And it is
Inside the
encapsulated
VXLAN
inside.
header. And this is for your VXLAN purpose. So source and destination will be your TEP devices.
Okay. Then VTAP. What is that Ethernet one? The top one?
This one.
Yes, yes, yes.
This is the Ethernet frame. By looking into this, see, once it is encapsulated, where the traffic should go? It should go to the other tunnel endpoint, right?
Tunnel endpoint MAC address.
This step MAC address will be there in the Ethernet header. Source will be this step MAC address. Destination will be this step MAC address. Here in this Ethernet header, source will be the source VM's IP address, and destination MAC address will be destination VM's IP address. Sorry, MAC address.
Okay. Okay.
Is that clear?
Yes. So before that, ARP will be get result, right? Then only
Yes.
it will send the packet.
Yes.
Okay. Okay.
Yes.
Got it. Yeah. Thank you.
Those are normal, whatever is happening in the normal networking, those all activities are required here also. All right. So now I specify all these.
I'm writing it. Just a minute.
Okay.
Yeah, you can go ahead.
Okay. So once we give all these parameters, then we will say add. When you click on add, that particular uplink port group will be added here. Okay. So you will get a additional entry. And this port group, this uplink profile can be used when we configure our host preparation, when we do our host preparation. So two things we did now. One, we defined the transport zones. Two type of transport zone. One is overlay transport zone and another one is VLAN transport zone. Right? That we defined. Second, we created a uplink profile. This will tell how the NIC cards of your node need to be used for your NSX-T purpose. Right?
Yeah.
So there are two type of, yeah, I think quotation. Two type of transport zone. One is VLAN transport zone. What is the other one?
Overlay transport zone. Overlay transport zone is for your VXLAN traffic and VLAN transport zone is for your VLAN traffic.
VLAN transport zone for VLAN traffic and
overlay transport zone for your VXLAN encapsulated traffic.
Okay. So right now we discuss, right? It is a VLAN transport zone.
Transport zone was yesterday's topic. Today what we discussed is only the uplink profile.
VLAN. Okay.
What we discussed now is transport VLAN, not transport zone.
Zone.
Any question?
Koteshwar Rao asking.
No, nothing from my side.
Okay.
All right. Now, I told you our ESXi servers are acting as steps who is doing the encapsulation and decapsulation. And just in previous slide, I told you in the VXLAN header, this is your original Ethernet, then VXLAN header will be added, then UDP header, then IP header, then Ethernet. Right. So in this IP header, what is the source and destination? The source step device's IP address and destination IP address will be destination step device's IP address. So that means inside your host, when he do the encapsulation decapsulation, he is using a IP address which is actually doing that encapsulation forwarding the traffic, right? So what is that IP address? From where they will get the IP address? That also we need to define. So that is what we define using our IP pools. Okay, so till now what we configured is in system tab. Now it's IP address configuration. It is networking part, right? So we'll go to the networking tab. Inside that bottom, you will see IP address pool. And we have your IP address pool and IP address block. So you select IP address pool and click on add IP pool. So it will ask for a name. And here it will be 0 when you do for the first time. If you click on that, you will get this new window open. So here you can add your IP address. Okay, so you can define your IP address range. And once you say OK, you can save it here. Okay, simply here we are saying a range of IP address which can be assigned to these devices when NSX-T manager does the host preparation. So when he install the modules to this server, he will assign one IP address also to him. From where? From this IP pool, whatever we are configuring here. Simple, right? Any question?
Yeah, for there are some individuals, right? Like Ethernet, IP, UDP. So for them, the IP pool can be, I mean, these can be assigned to some IPs, right? I mean,
Your
yeah.
Ethernet is layer 2.
Okay.
Packet is your layer 3.
Okay.
Segment, that is your TCP or UDP, that is your layer 4. Okay. So only your layer 3 need IP address. This is your port number. This is your MAC address.
Okay.
So once you prepare your host, you need an IP address for communication, for the TEP functionality. So what NSX-T manager will do, he will pick one IP address from this subnet and he will allocate it to this step. And he do next host preparation, he'll pick another IP address and he will assign it. From the pool, he will assign one IP address to each device.
Okay. Got it.
What is VMK port or VMK NIC? What is VMNIC? What is VMK NIC?
VMNIC is nothing but virtual machine NIC. I mean, virtual NIC of a VM.
Virtual NIC of a VM. What is VMK NIC?
There is a uplink NIC.
You have a server configured with ESXi or installed with ESXi. How do you access that server from your PC? This is your PC, you are sitting here. This is your switch. So your PC is connected to the switch and switch is connected to the server and server have ESXi installed. How do you access this ESXi in this PC?
I think our diagram is okay. ESXi.
So with that ESXi IP slash UI in the
So you
address
will
bar.
type the IP address of ESXi, right?
Yes. Yes.
In the browser.
Yeah.
Now tell me, where is that IP address on this server? Where you are configuring. When you assign a IP address during the ESXi installation, where is that IP address is getting configured?
Yeah. Can you repeat the things?
See, when you install your simple question, straightforward. Okay. When you install a ESXi on a server, it will ask for IP address, mask, and gateway, right? So we are giving the IP address for that particular host. My question is, where is that IP address getting assigned?
Some DHP server.
If you have a laptop and you are assigning an IP address, where is that IP address getting assigned? Your laptop will have a NIC, correct?
NIC.
Yes. Physical NIC.
And this IP address is getting assigned to the NIC.
Oh, okay, okay.
If you have two port, you can assign two IP address, correct? Because you are assigning IP address to the port. So each port can have its own IP address. My question is similar to this. If you are doing an IP address assignment on on ESXi, where is that IP address getting stored or assigned? Is it on NIC?
Yeah, NIC only. Yeah.
It is on NIC.
Yeah, it's on NIC.
It is not on your NIC.
Oh. VMK NIC. Okay, then in that case, some software. VMK NIC.
Which software? Where?
VMK NIC virtual VM NIC VM.
The physical NIC can be used by this ESXi.
No.
VMK NIC.
Inside your ESXi.
That's what we are installing that ESXi in the physical machine, right? So the physical NIC card will be used by ESXi when we install that.
It will be used, but not IP address assigned there. Okay, so when you install ESXi, you have a vSwitch 0, right? vSwitch 0 will get deployed automatically when you install ESXi. And on your vSwitch 0, you have a port group.
Correct. Port groups.
VM port group, VM port group, and VM kernel port group.
Yeah.
So you have VMK0. VMK0. This is a virtual NIC, or we can say virtual adapter on your vSwitch 0. This interface is actually getting that IP address. Okay. And your server will have a NIC card, 4-port NIC card. These NIC cards are connected to the vSwitch 0. These NICs will not have any IP address. Okay. So this is like one switch is getting connected to, right, from the server, the ports will be going out and it will be connected to a physical switch. So that is the reason the server NIC cards are called uplinks. It's acting like a switch to switch connection. That is why we created uplink profile. We said how the uplink need to be used. The previous slides we discussed about uplink profile, right? We said how this NIC need to be used. There we didn't specify any IP address, right? So your IP address, when you install ESXi, IP address is getting assigned to your VMK0. Like this, you can create n number of VMK ports, VMK1, VMK2, VMK3, and you can have n number of IP address also. So anytime if you deployed a data center, then you will be aware, you will have a management IP address. You will have another interface for your vMotion functionalities. You will have another interface for your storage access, NFS or CFS access. Like that, you have multiple interfaces for multiple purposes. So one ESXi can have multiple IP addresses. Fine.
Yeah.
So using this IP pool, at the time of host preparation, I said one IP address will get assigned to the each node, right, for VTAP functionality. So this IP address is getting assigned to VMK10. So NSX-T uses VMK10 interface on your nodes for using it for VTAP functionality. Fine. So you learned a new thing about ESXi today, right?
Yeah.
Okay. There are a lot of small things. Okay. As and when it comes, we'll discuss. Okay. Next is transport node profile. So what are the things we discussed? One, we discussed transport zone. Second, we discussed uplink profile. Third, now we discussed about IP pool. Okay. Now fourth, we are going to discuss about a transport node profile. It is nothing big. We are going to bind all these informations, but we need to say, right, we can have multiple transport zone, we can have multiple uplink, we can have multiple IP pool, but when I do the host preparation, I need to tell out of these things, which are the things which I need to use for the preparation. For that purpose, we are using the transport node profile. Transport node profile will pick one transport zone or two transport zone, uplink profile, IP pool, and other parameters required for your node preparation. So transport node profile defines different parameters need to use for the transport node preparation. Okay. All right. Transport node profile gives the power of speedy deployments and avoids any manual error. What is this? See, the previous class, I told you I can prepare individual hosts one by one. So what happens? Every time I need to tell what is the transport zone I need to use, what is the uplink profile I need to use, what is the IP pool, and all other parameters I need to tell for each and every node. So I'm repeating it. So the configuration task is more. I may create manual errors when I do that. To avoid that, we are creating a transport node profile. And now onwards, whenever I do a host preparation, I will simply say use this transport node profile. No confusion, no mistakes. Okay. Okay. So from 3.0 with 7.0, vCenter or ESXi 7.0 and NSX-T 3.0, we have an option to use distributed DVS switches, which is part of your vSphere, or you can use the older way of using NVDS for the networking functionality. So we have both options starting from 3.0 version. Okay. And edge clusters, still they can only use NVDS. Okay. Newer version will confirm it. So as I know, till now, this is using NVDS only. Maybe they introduce in recent version, I'm not sure. Okay. Okay, coming to the transport node creation. So we are again going to the system tab. Here on system tab is there, fabric, profile. Then you will have a transport node profile here. Okay, inside. This is the first tab, second tab, third tab. That's the transport node profile. So when you click on add, we'll get this window. So here we are giving a name for the transport node profile. I'm saying transport TNP, transport node profile, ESXi. Any name you can give. Your name also you can give, not an issue. Okay. Now, whatever the transport nodes transport profile, transport zones you created, those all will list out here. You can take that and you can click on this arrow, so it will be selected. So this box is for selected transport zones. Okay. Your normal nodes, transport nodes, except your edge node. We discussed it in the previous class. So normal transport nodes need only overlay transport zone because they handle only the encapsulated traffic. But your edge nodes are talking east-west, right? They are handling east-west and north-south traffic. Both should come. So VXLAN traffic will come here. They need to do encapsulation, decapsulation. When the traffic goes out, they need to do the VLAN handling also. So these nodes will have your overlay transport zone and your VLAN transport zone associated. Okay, so now we selected only overlay transport zone. Now we'll say add. So we'll go to the second tab. So in second tab, what are the options? We have many things to set. One, we are giving the NVDS switch name. We are giving a name to use for the transport zone switch. Then NIOC profile, network IO control. These default profiles are already there. That's why we are not creating it. There is no reason for us to modify it. And uplink profile we saw, we are selecting that uplink profile which we created. LLDP profile, we already have default LLDP profile, so we are just calling them. IP assignment. So we can say use IP pool. When you use IP pool, here drop down, you can select what is IP pool you need to use. And here we are saying what are the physical NICs we are going to use. We will say VMNIC 2 and VMNIC 3. Right? Those are mapped to uplink 1, uplink 2. Then other informations are not required. So when we see these all what we configured before, right? We created uplink profile, we created the transport zones, and we configured the IP pool, and all those things we are mapping or we are defining inside your transport node profile. We are making a relation between all these things, and we are saying add. We say add, that transport node profile is created.
Shumar, I have one basic doubt. What is the difference between transport node and the edge node?
Edge node is also a transport node means any device who is actually doing the TEP functionality in simple terms. Okay, so any device who is handling your who is doing your TEP functionality is your transport node. So here encapsulation decapsulation is happening. Here also we have so many VMs, right? And this is edge node. Edge node also, right? When he receives the VXLAN traffic, he is doing the encapsulation and he is sending additionally VLAN. So these all devices, these all we call them as transport nodes.
Okay.
And edge node is also a transport node, but as he is involved in north-south traffic communication also, that is the reason we are calling him as edge node, because he is sitting at the edge of your data center. After this, it is going outside your data center. So transport node is of two type, a normal transport node, or we can say this is correct. So transport node, a normal transport node or a edge node, or we can say nodes are of two type. One is transport node and another one is edge node, but edge node is also a transport node.
Yeah.
So we defined our transport node profile. Now what is that we need to make? We need to use this transport node profile and we need to prepare our nodes. Okay. So on your UI, we are going to system nodes. There you have host transport node or edge transport node. Okay. So if you have your vCenter server integrated with your NSX-T, then you will have an entry like this, which is your vCenter server. Or you will have only this entry. If you don't integrate, if you don't have an integration with vCenter server, then only standalone host it will show. If you use standalone host, then for each and every host, you need to keep on giving all the parameters manually. That is very tedious. So easiest way is select your vCenter server, integrate vCenter server, then select your vCenter server. So once you do that, it will list out all the clusters you defined inside your vCenter server will be pulled to NSX-T manager, and it will list out. It will show all the things. See here, we selected same page. Okay, so system, fabric, node, and under host transport nodes, we are selecting the vCenter server. Once you select the vCenter server, see the clusters, edge cluster. There are 3 nodes, 3 servers, and compute cluster. There are 3 nodes. So it will show all. These are, we didn't configure any of these. We didn't say that, okay, these hosts are existing. But he pulled all those details from the vCenter server and he is displaying here. Now, very easy, you can simply tick the cluster. When you tick the cluster, all 3 nodes inside that is included in that, right? Then click here, configure NSX.
Okay.
So you will get this pop-up. There what you are doing, you are just selecting the transport node profile. This is the name we created, right? TNB ESXi. We are just defining, saying that use this profile and prepare this cluster. When you say prepare this cluster, prepare all the nodes under that cluster. Now you will say save. When you say save, see, you will be able to see the status here. It will take some time. Okay. So it will show it is doing installation, it is doing that configuration, this, that, multiple things you will see. And finally, you will see success and up. Straight to your
These 3.
cluster, straight to the cluster, it will show how many hosts are up, how many hosts are down.
So these are cluster edge clusters, or this one are normal.
This is the normal clusters.
Normal VM. We are
Normal host transport node, not VM. These are the ESXi nodes.
Okay. 3 ESXi nodes. Okay. And then we are making as a transport node.
Yeah, this is the edge node that we are not talking now. So we have a cluster. This cluster is your workload cluster.
Workload cluster.
Workload cluster, where you have your VMs are running, your what services are running, web server, database server, all those things are running here. This is all ESXi. Edge node is also ESXi, but we are not talking about edge node now because that is in a different cluster. So we just selected this workload cluster and we did preparation. So these 3 nodes under this is prepared. Now I need to select the other cluster. So what is other cluster? See, edge cluster is there. If you select that and you say configure NSX and select the profile, save, then it will do the preparation for other cluster also.
So there are 2 type of clusters. One is a workload cluster, that is a ESXi. That edge also it's a ESXi, right? Then there is a edge cluster, workload cluster and edge cluster.
So you understand one thing, don't confuse. There is a possibility for a confusion here. These clusters got nothing to do with your NSX.
Okay.
This is pulled from your vCenter server, right? It is pulled from the vCenter server. So whatever you configured in that vCenter server, that will display here. Not only 2 cluster, you may have 20 cluster for different purposes you may have. All those 20 cluster it will show here. Okay. So what the cluster name here it is saying edge cluster, right? That name doesn't matter. Here it is saying compute cluster, name doesn't matter. In NSX-T, which cluster we are planning to use it as a transport node, which cluster we are planning to use it as a edge node, that will be actually acting as transport node and edge node. Okay, so this is just what we configured in the vCenter server. So normally when we do it, we will give the cluster configuration according to what we are going to do in the NSX-T. So if you think in that way, that is correct, but it need not to be right exactly matching with the terms what we are using in NSX-T. It need not to be on your vCenter server.
Okay, workload cluster and edge cluster.
So here you will see the transport zones assigned to those devices. Here it will show the NSX-T version, which is that I told you, right? Host preparation means what? He will be installing different modules into this ESXi. He will allocate an IP address. He will create a NVDA switch, that is a NSX-T functionality switch will be pushed into the host. Then there will be a connection communication established from your NSX-T manager to this. If manager cannot communicate with this node, then there is no use, right? So there will be a communication established between them. So all these preparation, all these process after that, you will see status success. Okay. Now, how do you do? Now what we saw is how do we prepare the host transport node. Now we are going to see how do we prepare for your.
Hello.
Yeah.
Okay.
Okay. So similar to what we did for transport zone, we can we can select the other clusters and we can do the ESXi installation. So for a edge cluster, if you have 5 nodes, these are prepared, right? How we prepared it. We need not to prepare these edge nodes, not required. Why? Because these are the ESXi nodes, but they are not actually acting as edge. We will deploy a VM on top of that, and that VM is actually acting as a edge node. So when you deploy edge nodes, automatically he will have all the VTEP modules, all those information, everything will be available here. Okay, we will see that. All right, some verifications. So if you go to your transport node, if you go to your host transport node, then if you click on the right node under that cluster, you select that, you will see a switch virtualization section. If you click on that, you will be able to see the new NVDAs created, the TEP IP address allocated. Okay, so this information you will be able to see. See here, VMNIC0 is mapped to your vSwitch0. This is your physical adapter. And VMNIC4 is mapped to your DV switch. And NVDAs is showing here with the TEP IP address. And you can see another DVS with another uplink. So how many switch you have, how you did the NIC mapping, that you will be able to see in this switch virtualization section. And if you go to your vCenter server, see, this is not NSX-T UI. This is your vCenter server or vSphere client. So if you go to the node, if you select the server, go to configure, go to virtual switches, you will be able to see here, DV switch, standard switch, and VDS. This is for NSX. Okay. So which switch you select, that switch diagram it will show below. So now this is expanded, right? Arrow is below, towards down. So this showing, it is showing now NVIDIA switch details. If you click on vSwitch 0, then here you will see the vSwitch 0 diagram. You select this, then you will see a DV switch diagram here. And if you go to your server, again configure, Previously we verified virtual switch section, right? Now if you go to your physical adapters, then you can see the NICs which you selected is mapped to your NVDS. Okay. Now if you select VM kernel adapters, VM kernel adapter is what? I told you inside ESXi, the virtual adapters, virtual interfaces, which is getting the IP address assigned. That is the VM kernel adapter. You select that, then you will see VM NIC 10. See VXLAN, right? VXLAN means your NSX-T functionality. And the IP address, this will be from the pool which you created. This will be one of the IP address from your pool. Okay, so whatever we configured, we can verify it inside your vCenter server. Any question? Okay, from the NSX-T UA also you can see the same thing, your NIC details. From your transport node section, if you select your node, there you will be able to see transport node status, network interface. So if you select the network interface, you will be see the network details. Again, this is same. If you select the TCP IP configuration section, TCP IP, so see, we verified virtual switch. Next, we verified a VM kernel port, physical adapter. If you select the TCP IP configuration, then you will see there is a TCP VXLAN protocol stack is installed. This is packet capturing. Okay, so how is your VXLAN header is? See, how do I explain this? This is a Ethernet header, IP header, UDP header, user datagram protocol, right? UDP header, and your on top of that, you have your VXLAN. Right. And again Ethernet, and again IP, and this is ICMP. So this is not a normal data communication. This is, I think it is a capturing from the ping packet. That's why you have ICMP. Okay. So this is your original data. On top of that, VXLAN header is added, then the UDP, then the IP, then the Ethernet. This is what we discussed, right? But I drawed it like this. This is my original data. Original data means I just showed Ethernet. But inside Ethernet, what do you have? You have your data, actual data, then you have your UDP, then your IP header, then your Ethernet header. This is the actual full original data. Then on top of this, VXLAN header, then your UDP, then your IP header, then your Ethernet header. Same thing, no? But only thing is it is showing in on top of, and I showed in right line. That's it. Okay. Yes. I told you, right? The host preparation will push many modules, WIPs into the ESXi. See, ESXi software web list, and I'm grabbing using NSX keyword. So these all are the modules. These all are the modules which is getting installed as part of your host preparation. So once these all modules are installed, and once they start running, if they can make a communication channel established between your NSX-T manager and this node, then everything is good and fine. So this is a communication. This is not important. Okay. So this is what is happening internally. So how these different components are talking, what is the port number they are using, all those stuffs. This is not important for us. That's it. Host preparation is over.
Okay.
So what are the steps? See, we'll start from the beginning. Okay, the whole thing I will explain. So we have a normal ESXi vSphere installed data center there in the data center. What we are going to do is we are going to prepare that data center for NSX-T functionality. So what is the first thing we need to do? We need to deploy our NSX-T manager. How you will deploy? Your normal OVA deployment procedure, what you did in ESXi classes, right? When you learned ESXi. So you will deploy using OVA, you will deploy your first manager. Now, what is recommended? We need 3 managers, right? So additional managers, you have 2 options. One, same procedure you deploy using OVA 3 times, then manually put them into cluster. These are all manual tasks. This is one way. Or second way is you integrate your vCenter server, your NSX-T manager. Once you integrate the NSX-T manager, sorry, vCenter into NSX-T manager, third, log in into your NSX-T manager, and from there you can say deploy additional appliances. So 2 more click, you will get additional 2 more vCenter. So this is easy. These 3 VMs will be 3 NSX-T managers will be deployed. Automatically NSX-T manager will take care of the cluster configuration, the syncing between them, everything, and finally it will show the status app. Okay. So now your NSX-T manager is ready. Now what is next? We need to do the host preparation. For doing host preparation, that means preparing your nodes for doing NSX-T functionality, we need to do some pre-configurations. What is that? One, you need to define a transport zone. Second, you need to define uplink profile. Third, you need to define IP pool. Fourth, you need to define transport node profile. Then fifth, log into your UI and you say do the transport preparation, right? Transport preparation, you will say host node preparation, you will refer this transport node profile and your host will be ready. That's it. Over. This is what we discussed till now.
Which is a seeded series and which is a custom series. So generally what we suggest, or when we do implementations, right, or when we are creating a new custom series, we try to give a certain naming convention so that it can be easily identified or differentiated, which is a seeded series and which is a custom series. Okay. So before creating a series, right, I think last time we stopped at a lookup properties. Quickly I go through the remaining properties also, and then we'll try to create a new series. Okay. So I'll go to the data properties. So this is one of the main data property. So I'll take the same series example which we discussed last time. So this is one of the important data properties in a series definition. Okay. So data table specifies on which table you are trying to create a series. Okay. So series is nothing but a placeholder to store some data. So whenever creating a series, you should mention to which particular base table the series has to be attached and which column it refers. Okay. In this case, for example, there is history series